Good morning, everyone. I hope you had wonderful lessons for the past 2 days. Today, I would be your instructor for Python, and I'd take you through Python from where you left yesterday. So, are we expecting more people? If someone can just unmute and tell me how many you were yesterday, and are we expecting more, so that I can know if I should wait for 5 more minutes before starting the lesson, or I can just start. Thank you. Hello, can you hear me? So you can just write on the chat how many you were yesterday, so that I can know if we can start, or we can give people a few more minutes to join in.
Good morning, everybody. Hi, Kauta.
Good morning, Toby. Hi. Okay, so if you are 30, I'll give people 5 more minutes to join in, then I can start.
Kauta, did you see the message from Jean saying that he won't be able to join today?
Yes, I did. I saw it, but I've not responded to it yet.
Sure. So would you like me to teach part of today, or are you planning to cover the whole session?
I can teach the first hours before the main break, then you can continue after that.
Okay, that sounds good to me. Yep, thanks.
Okay, thank you.
Morning, everyone. Morning, colleagues.
Hi, Aluani. How are you?
Yes, I'm good.
Hello, Alwan. Hello, everyone. It's now 10 past, and I would begin with the lesson. For those who are not there when I introduced myself, my name is Kauthar Omar, and I would be your instructor for today. Feel free to stop me at any point if you do not get something clearly, and ask questions. I hope to keep this as interactive as possible. Thank you. Can you see my screen? Okay.
We can, yeah.
Yes, so yesterday you were introduced into Python and taken through the fundamentals of Python, which is basically the basic arithmetic operations and in Python. And you also started on analyzing patient data, where you are introduced to the library in NumPy and some few basic operations in NumPy, such as importing, loading the TXT, and also indexing. So today I'm going to continue and pick up from where you left yesterday and continue to give you some insights into NumPy. So I am aware you went through loading the TXT file, looking at the data type, looking at the shape, and also indexing via rows and columns, and slicing the data, and also analyzing some of the data using some functions like min and max and std, and you reached at the mystery of functions in Python. So if all, I hope you all have opened your notebooks so that we may continue from there. So in Python, when you're using NumPy or any other library, and so if you have not loaded your data frame, please, if you've not loaded your array from the data file, please do load it. And it's simply this way. So first import NumPy if you've not imported NumPy. So I have already imported NumPy, but I will just, sorry for that. I'll just import it again. So, and after importing NumPy, you can load the same data that we were using, you were using yesterday, and assign it to the object data. So it's check where the path to your data. So for me, this is the path to my data. And if I want to have a look at it, I can have a look at it. And so after you do that, I will go straight to where you left yesterday, which is the mystery of functions in IPython, where when you want to use, you do not know what the functions that NumPy has and what operations you can do with NumPy. So you write NumPy, then you tab complete to see the operations, and you can actually see the different operations NumPy has, and you can select the one you want. So for example, if you want to check the maximum, you can do that, and you can put that and see what the maximum value in your array was. And also another interesting thing is to use the question mark to actually look at what the attributes of the functions actually do. For example, in this, in our case, we have the Emacs, so we want to see exactly what it does. So we will do NumPy .emacs. Then you can put a question mark. Sorry. And then when you run that, it actually shows you what it does. So it tells you it returns the maximum of an array or the maximum along an axis. So if you specify the axis, it will give you the maximum along the axis or the maximum of the array. Then it goes ahead and actually like explains the parameters, what they are, what they do. So you can use this for any attribute of any function in Python. So for example, in the example given in the Carpentries notes, it's numpy.camprod, which gives you the cumulative product of an element. So basically any attribute of any function that you saw that you want to see what it does, you can easily check it with this. And if not that, you can, another way of looking at it is using help. So you can actually just use help to do that. So you write help, then you put brackets. Then you remove the question mark and you run it, and it gives you the same output, which it shows you what the function does. And so you can do this for all the functions that you used yesterday, or for any other function that you would like to explore today. So another thing I want to take you through is when you want to subset your data. So if, for example, this data, we want to look at patient 0, which is row 1 and all the columns. So this is how you subset if you only want to extract data for patient 0. So this, what it does is in the array data, it selects so in Python, it starts counting from 0, not 1. So it selects the first row and all the columns in the first row. So you can use, I'm storing this into an object called patient 0, and then you can do any operation. For example, here you can see they want to see the maximum inflammation of patient 0, and you can use the attributes Emacs that you learned. So this you can combine print with the function too, and actually extract that information. So, or you can run it step by step to actually see. So if you want to get the maximum out of this, and see exactly what is happening, you can literally print the patient 0 first. So you see it has taken all the values of the first row. Then you can actually look at the maximum inflammation. And when you confirm from this, you actually see that it is the maximum inflammation. You can also do the same for patient 2, patient 3, and you don't necessarily have to assign it to an object. For example, in this case where patient 2 is the third patient, so you can actually just print it directly as they have done. Instead of assigning it to an object like this, you can just say numpy.amax, then select the array, which is data, and subset the second row, everything in the second row, and do the operation amax and assign it to the string which you will print, which is the maximum inflammation of patient 2. And in this way, you can actually gauge the maximum inflammation of patient 2, which is 19. So if you really want to see what is happening, you can run it step by step, like I did in the first example. So if you want to see like the maximum inflammation, whether it is for all patients or for every day, you can use the axis. So for a two-dimension array like the one we have, which on this side where we have the patients, and this side we have the days. So if we want to check the maximum inflammation on each day, we are going to use max axis 0. If we want to check the mean inflammation on each day, we are going to use mean axis 0. So what axis does is it checks, depending on how you specify it. For 0, it looks against all the columns, and for 1, it looks against the rows for a two-dimension array. So for this command here, what we see is we will get the mean inflammation for each day, because axis 0 looks at the columns, so you get the mean inflammation for each day. Feel free to stop me at any point if there's something that is not clear. So for these values, we see the 0 is the mean inflammation for day 0, for day 1, for day 2, for day 3, like that. So if you want to get the mean inflammation for each patient, all you need to do is to change the axis to 1. So instead of like subsetting each time, you can actually use axis to get this information. So if you want to see quickly the mean of all the columns, you can actually just do mean. If you want to see how many columns, how many days there are, or how many values there are for mean, you can actually do dot shape where you get 40. That means there were 40 days, because shape shows us the shape of your output. So if it is an array, it will give you rows and columns. For this case, where we only have one row where it gives us the mean of each day, so the dot shape will actually give us how many values do we have, which is how many days did we have. So this, it's 40 because initially, if you go and look at your the dimensions of your data, it was 60-40. That means it had 60 rows and 40 columns. So if it does the mean for each column, we actually do get 40. So I'm just gonna quickly run this so that you can see. So here it is as I had explained. So the same thing, if you want the mean per patient, as I had explained earlier, you're going to use axis 1 and you will get the mean per each patient. So across all the days that were there, so from day 1 to day 0. I am seeing someone asking where to get the notebook. So for the notebook, you should have it. You should have from yesterday, the notebook that you used yesterday, you can actually reopen it and continue from there. So if you can just unmute and ask exactly where you are, and I can assist you in finding your notebook. Okay, if you've solved that, that is fine. So yes, in case you have a problem, you can just feel free to stop me and ask me. Yes, so here when we were doing the numpy.mean axis 1, we were getting the mean inflammation of each patient for all the 40 days that were there, and that was it. So the next thing I'm going to look into is slicing strings. So what is to slice? The same way we did with the arrays. So a slice is actually just to get a section of something. So whether it's depending on what you want. And for example, in this example, I'm going to paste it into the console, into the notebook first. Then I can explain it to you. So the string oxygen is assigned to the object element. And in this case, we actually want to print the first 3 letters. And I hope you did learn this yesterday. So the indexes of Python 1 start from 0. And if you put 3, it will always do 3 minus 1. So if you want to get the first letters, so this is 0, 1, 2, you have to put 3 because it takes the number you have put here minus 1. So if you run this, you will actually see for the first 3 letters and also for the last 3 letters, you put 3 to 6 because this is 0, 1, 2, 3, 4, 5. So you put 6 because it is n minus 1. So 6 minus 1 is 5. We will get the next 3 letters, which is GEN. So this is how you get a slice of a string in Python. For example, in this case, our string oxygen. So what is the value of element colon to 4? And what about 4 colon or element with a colon? So can someone, without even running it and just thinking through, using the same thought process we did when we were looking at the arrays and slicing the arrays. Can people put in some answers? I'm giving you 2 minutes to think about it. Kindly don't look at the solution first. So I can see someone has written the answer in the chat. So you can write A, B, and C just to show exactly what you mean. So A for this one, B for the second part, and C, and put your answers in the chat. Thank you. Please don't run it fast. Just try to think and put your answers. Then after that, you can run it and we can all see what the solution was. Anyone else apart from Mutembe? Okay, so 2 minutes are over and I'm just gonna run it so that we can all see what we actually do get when we look at, when we slice this. So yes, when you slice selecting 4, so what it does is it prints everything up to n-1, which is 4 minus 1. So you get 0, 1, 2, 3, you get the first 4 elements. So the second one was when you interchange it, what do we get? So we get from the fifth letter to the end, which is E and N. And if we use just the colon, we get everything. And when we use, and for this case, I saw there were some answers in the chat. Yes. So let us see, all of us, if this is the case. And please be trying to actually think about it, then run the codes just before you look at the solution to actually see if you are understanding and, you know, getting the, trying to see if you're getting the concept of slicing or what would. So for the -1, it gives us the last element. So if when we have a negative, it starts counting from the end. So if we put -1, we get the last letter of oxygen. And if we put -3, we get the third last. So we start counting from the last. So this is -1, this is -2, and this is -3. So whichever number, if it's a negative notation, you start counting from the end. And if it's positive, you start counting from 0. So there is also this other exercise. I will skip this and we'll look at this. Thin slices, the expression, the object element 3:3 produces an empty string, that is, a string contains no character. If data holds our array of patient data, what does data 3344 produce? What about data 33 and a colon? So can we have some answers in the chat? Would someone want to try this? So I'm giving you 3 minutes to think about it. Anyone with any thought process, what they think that we would get and why? Someone can put that on the chat. So Mutembe is saying, because we start at the fourth character and end at 4 minus 1, I thought it was data 3, 4. Yes. So this is very good because you actually can't, the thought process is actually correct because you cannot subset. If you remember, you start at the fourth element and you end at the fourth element minus 1, which is the third element. So you will get an empty string because you cannot create slices like that. And also for this, for the first one, you will get, if you check the shape of this array, you will get 0, 0 because you did not slice anything, you did not select anything. But for this one, for the rows, you did not select anything. But for the columns, you selected everything. That is why you are getting the shape 0, 40. So it selects nothing in terms of the rows, but in terms of the columns of the arrays, it selects everything. So when you are writing your slices, you should actually think, how am I slicing my data set? Are the indexes that I am using correct? What are the implications of this? And if you are running it on a bigger data set, you can always test it separately, then now incorporate it into your code. So another thing that NumPy does, it can stack data sets, and there are 2 types of stacking. We can either have the horizontal stacking or vertical stacking. And to illustrate stacking, we are going to use this array that has 3 lists, 1 of 1 to 3, 4 to 6, and 7 to 9. So since we have already imported NumPy, you do not need to import it again. So you can just assign the array of lists to your variable A. And if you want to see exactly what A has, you can actually print it, but so that we do not, we do not confuse it with any other operations that you're going to do. And here, since they have all of them together, you first print the word A, and then you print the object A itself. So this is just to print the string A equals to, then now you can actually print the object A itself, and you can see the array of lists. And if you want to stack, you can either do the horizontal stack or vertical stack. And if you're not sure how it works exactly, you can initially just, you can look at the functionality using what we did initially. So you looked at stacks arrays in a sequence horizontal clockwise manner, and you can see exactly how it is done and all the options that are available under that. And then you can now come and execute your horizontal stack, which in this case, we want to stack A, and we want to assign it to the object B. So here we are doing a horizontal stack of 2 A's, and we are assigning it to B. So you can see how it's horizontally stacked. And if you want to actually see what is the difference between horizontal stacking and vertical stacking, you can do the C and see this. So for the vertical stacking, you can see that we first have the elements of the array at the top and the other A below it, but with horizontal stacking, we have side by side. With vertical stacking, we have one on top of the other. So all these are, we can try this, change inflammation. So if the shape of an individual data file is 60-40, that is 60 rows and 40 columns, what would be the shape of the array after we run the diff function and why? So I know I have not introduced you to the diff, but what do you think would be the difference? What would it do? I'm giving you 2 minutes. Okay, since nobody has answered, I'll just say, so what diff does is it takes an array and it gives the difference between two successive elements. And for this case, if we have our array of 60 by 40, and we look at the difference between two successive columns in our case, what do you think would be the shape of our array and why? So let us just do this practically. So we have data. Which was our array. So if we want to check the shape, what do we do? Data dot shape. So our shape is 60-40. And if we use, let's assign it to the object diff data. And use oh, sorry. So if we check this, so this is our array, but if we want to check the shape of the array, what do we get? Oops. So why do we get 39? Because it checks the difference between two successive values in a row, and it returns the differences. So since it does for the first two, second two, we will have one less column. That is why we still have our 60 rows, but now we do have one less column. So I would wrap up this lesson by just giving a quick recap on it. So the first thing we learned was how to import a module, and we used import with the module name. And we also learned how NumPy, we learned about the NumPy library and how to actually use it to read in our array, to look at the shape of our array, and also how to get indexes. And in Python, our indices don't start at 1, but they do start at 0. So if you put 2, you actually do get the third element and not the second element. And also how to slice our data and just get a section of our array. And also how to do some simple statistics using NumPy, such as getting the mean, the maximum, the average, and how to incorporate axes in our two-dimensional array, which we had, where when the axis is 0, the operation is done along the columns, and when the axis is 1, the operation is done along the row. And in the case of our patient data, we saw that if we want to get the mean of the number of days, like day 1, day 2, we can actually use axis equals to 0. And if we want to get, let's say, the maximum value of the maximum inflammation in a particular patient, we can use axis equals to 1. And you can actually interchange this with mean, max, depending on exactly what you would like to get out of your array. And this would give you the expected output. So just before we go to the next section, I'll give you a 5 minutes break to drink water, and you can also ask questions on the chat for a section that was not very clear. And exactly at 10 sharp, we can start on visualizing tabular data. Thank you. Uh, Hello, everyone. Are we back? Can I get a yes if you're on the call so that I can share my screen and you can continue? Thank you, Charlene. Yes, so I think I have enough thumbs up and yeses, so I'll just share my screen and we can continue. So now we'll go into visualizing the tabular data. So we have been doing some basic operation, getting the minimum value, getting the maximum value, and looking at how we can look at the different, we can do different operations using NumPy. And so for this lesson, we are going actually to use all those operations that we did using NumPy, and you're going to generate simple plots, and you're also going to generate multiple graphs in a single figure. So if you would like, you may continue in the same notebook, or you can just here do add another notebook, and you can rename it to whatever you want. Let's say lesson 3. So we will look at visualizing the data, and you're going to use the same CSV file that we did use in the previous lesson. And so that is the inflammation 01, and you can import the module and load your CSV, and be keen on the path. So if yours is exact on the same path like your notebooks, you can load it like this. And if it is like mine, so mine is first in the data directory. So this is how I actually do load my CSV. So for this, we are going to import matplotlib, and you're going to see an image of our data, and we are going to use the import matplotlib.pyplot. So we are going to use pyplot from matplotlib, and in this you're going to use the image show. So, and after that, we are going to show our plots, and we will have a heat map of our inflammation looking something like this, where we will have the blue pixels for the that represents the low values. We'll have and the yellow pixels that represent the high values, and we will see our data in the 40-day period. So you can just copy the code and paste it in your notebook and see. So if you just want to get a general representation of how your data is, and for this on the y-axis, you can see these are the patients, and you remember we had our 60 patients, and on the x-axis it is the days, and this is 40 days. So this is just a very quick heat map, just giving you a visual representation of how your data looks like in the 40-day period. but you may be interested in mining particular information from the data. So let's say you want to mine the average inflammation over time. And for this, we are going to use both matplotlib to plot, and we'll also use NumPy to actually get the mean. So if you remember when we said axis 0, it gives us the mean on the columns, and our columns are the days. So if we want to get the average inflammation for each day, we use numpy.mean, and we put our data, and we use the axis 0 so that it can get the mean on the columns, and we will assign it to the object average inflammation. And then we can plot our plots and assign it also to an object, the average plots, and then we can use matplotlib.pyplot.show to actually see our plot. So feel free to stop me at any point if there's something that is not really clear. So for this, we do get from day 1 to 40. So if you can remember in our previous notebook, when we were doing the mean of day 1 was around 0. So it gets the mean of each day, and it gives us our plot. And we see that the mean inflammation is this day 20? Yeah, I think just before 20. So we can see the trend, and this is better because it gives us a visual representation of our data, and we can see the inflammations from day 0, it's low, and it's peaks, and it goes down. Oh, someone was asking, do you have access to the document? Just a minute. I can just paste the link for you, except that my laptop is misbehaving. Okay, so just to bring this into perspective, I've put the link on the chat, and for this, in the website page, you could actually see like the yes, I do agree with Toby that it's good to type out the code so that you remember the syntax and remember how the code is. Okay, so basically, for this plot, I hope you have understood where first we are doing numpy.mean, which was from the NumPy library. We are looking at the attribute mean, and we are getting the mean of our data for the axis 0, and we are assigning this to the object average inflammation. And after that, that is when we are actually now using the other module we imported, matplotlib, to get our plot for the average inflammation. And then we actually do the matplotlib pyplot.show to actually visualize our plots. So we can generate another plot for the maximum the maximum values of inflammation at each day. So let us type this out. So we have our max plot. So for the max plot, we want to look at the maximum value on each day, but instead of assigning it directly to a variable, we can easily, we can do it by directly putting it inside the brackets of our matplotlib.pyplot.plot. So since we want to plot our, we are going to use that. .pyplot .plot, and we are going now to put in what we want to plot, and this is the maximum value of each day. So this is NumPy. So what was the function that we were using to get the maximum value? It is NumPy.amax. So, and then you're going to specify our data in the first place, which is our data. We assigned it to the object data. And since we want to do for each day, we are going to use the axis equals to 0 to get it for each day. And now if we want to see our plot, we can do the matplotlib.pyplot.show. And when we run this, what do we get? We get an error. Why? We misspelled the word axis. So you should be careful with your spellings. If you misspell a word, you actually do get an error. So Python is very sensitive. And so here we do have our plot of the maximum values, and we can see from the first day to day 40, it's giving us the maximum values, and we can see the trend in terms of inflammation. What is the maximum inflammation per day, and what trend does it show? And we are actually seeing our line graph here, which has a very sharp edge. Yes. And we can actually do this for different. We can have a plot for the minimum, where we want to see the minimum value of each day visually. And now we are going to plot our next plot, which is the mean plot. So for the mean plots, we are going to use the same thing. So, and when you tab complete, it actually, when you just start typing the first words and tab complete, it completes for you whatever you are typing, and you can even use tab to search. So if you want to see the different attributes or the different functions a library can do, you can use that. And when we want to look at pyplot.plot, and now what do we want to plot? We want to plot the minimum value. So per day, so we are going to use our the NumPy dot, then you can check like the different function, the different attributes of the function, and we can select, oh, sorry, this is the mean. We can select the mean, and now we can put in our data. And we can, since we want to do per day, we can use axis, and for our axis, we want it's 0 because we want to look at the columns, which is per day. And after that, we do matplotlib.pyplot.show to actually see our plot. And now we see the plot of the minimum value in each day from day 0 to day 40. And we can actually see the trend of the minimum value for each day. And the interesting thing is, if we want to visualize all these plots together, and we want to like see our first plot, our second plot, our third plot in one plot, and we want to have all this information together so that we can have a comprehensive understanding of what is the mean, what is the max, what is the average. And so if you want to view all this in one plot, you're going to like use the axis to actually specify the plots that you want to see. So, and you're going to use the method in under fig, which is add subplot. So if you add subplots depending on what you would specify. So the method add subplots, it takes 3 parameters, and it takes, these parameters are the different axes of the subplots, and you can add each. So someone is asking for the recording. The session is being recorded, and I think it would be shared. So if you're having internet issues and you can't follow through, the recording will be shared at the end of the week. So you can follow through where you are, and if I've not gone very far and it's just a small part that you don't understand what happened, you can actually just ask me to repeat, and I can let you know. How the recordings will be shared, I am not aware of that, and I think the organizing committee can tell us more on that. So yes, back to our plot where we were looking at combining 3 plots in one, which, so for this case, where we read we imported our modules, we do not need to import them again because we had already imported them. So the thing we will do is from here, where we are going to use matplotlib.pyplot.figure size, and here we would specify our figure size, the dimensions we want it to be. So for a 10.0 to 3.0, and we are going to use our add subplots to specify the different how we are going to arrange our plots. So for the first one, we will have, since we are having 3 plots, so 1, 3, 1, where we'll have it at the first position. And for axis 2, this is to specify we will have it at the second position. And for axis 3, we are going to specify how we will have it at the third position. And so this add subplot is what is used to actually add, it's the method that takes in the parameters to add the different plots, either from left to right or from top to bottom. So for our case, we are adding it from left to right. And now then, after we have specified our axes and how we are going to add it, we are then going to specify how we are going to plot. And for this case, initially we were plotting our plots without any labels. And since we are having 3 plots together, it may be confusing which plot is for what. So the axis.set y label, it adds the y label for each plot, and it adds for our axis 1. So since we are going to add the y label average, and we are going now to the axis.plots, and this is actually the place where it plots our actual plot. And since this is the plot of the average, you're going to use the method numpy.min, and you're going to specify our data and axis 0. So this whatever is in between the brackets is similar to what we are doing above, because we're just getting the other we are getting the plots we had generated, but now in one view instead of having them in separate views. So the next thing, we are going to specify the second label, which is the max, and we are going to specify the plots and how we generate the plots, where we'll use the numpy.amax. And for the third plot, which would be on the axis 3, we are going to specify the y label, which is the mean. And we are going to use the axis.plots, and you're going to use the same method as we used previously, numpy.amin, and you're going to specify our data and our axis. So for the fig.tight fit layouts is to actually have them compact and squeezed together. And then for the matplotlib.pyplot.save figure, this is to actually save this image that you have generated. So in this case, it's being saved in a file called inflammation.png, where we will, where if you put it inflammation.png, it would be saved in the current working directory that's in the same folder as your code. But if you have another folder that you have created, for example, if you want to save it under the data, you can add data/inflammation. And if you have created a folder for figures, you can add the folder name figure/inflammation, and it would be saved accordingly. But for now, we can just save it under image, and matplotlib.pyplot.show is the same. It's going to now show us our plot. So everything that we have been doing here, where we are specifying the axes, when we are setting the y labels, and when we're actually plotting the figures, it's going to show us all that visually and generate for us the plots. So it's good practice to type. I may copy and paste, but it's good practice to type it out so that, you can make those errors where you forget a dot and, your code doesn't run, and you remember, oh, the syntax should be like this. And it's especially in the learning phase, it's good to literally type out everything slowly and get to understand the syntax. So if for the importation, it is not necessary because we already did all the imports at the beginning of the notebook. So you can see we have our plots, these plots that we had generated up, and we have them like put together, the average, the maximum, the minimum, and in one visualization all together. And the axis set, as we had set our axes, so the average to be at the first point, the maximum next, and the minimum third after that. So for our importations, we had been importing with the full name import matplotlib.spyplot or import numpy, and every time we were using that module or we were using that library, we had to type it out in full. But there is a shortcut where you can import something with a short form. For example, you can import numpy as NP. So when you import it in this way, every time you need to use it, you don't have to like write numpy in full. You can just write np dot, and you can actually do the operation on it how you want. So the same thing applies to matplotlib.pyplot. You can import it as plt. So let's just reload our data. We had where did we load our data? Yes. So since we have already imported it in short form, so we can have data. And just to remember, up here, as you can see, we had numpy.loadtxt, but since we have imported it as np, we can just have np dot load.txt, and then now we can specify our values as we had up here, where we specified where our data is and the delimiter. So this is very helpful, especially when you have modules, very big names, and you do not want to be repeating the name all the time. So you just do this, and you can always be using it with the short form of the library name you used. So the same applies. Where it actually just imports it as it is, and you can easily be using it. So an interesting question is, why do all our plots stop just short of the upper or end of our graph? So we would, like, if we go back and look at our plots, we see they just end right before the end, or right before the end of our graph. So what matplotlib does is it automatically sets the axes as using the minimum and the maximum value. So we do not have to think about it, but you can adjust it and set your own axis with the dot set ylim, and you can set it to the minimum or maximum value you want, and have your plot with the axis you want. But if you do not specify it, it automatically sets the axes for you. So would you like a short break, then we can finish up, or would you want me to finish up right away? So we want to have a break now. Would you like the break, or would you like me to finish? Then so we have Busani saying we can continue. Okay. So I think we can continue, then take the break and finish this lesson. So from our plots, we have been seeing that matplotlib interpolates and draws straight lines between points, and you have been seeing that in all our plots. And if we want to avoid that, we can use the draw style option, and instead of getting like a straight line like we were getting in our previous plots, we can add the draw style mid steps to, actually not get a straight line, but have like small mid steps showing the different points of our data. Because if we go back and look at our initial plots, like we see it draws like straight lines between the points, and you may want to see your data in a way that you actually do, kind of see how the progression, you want to see how the change happens, and you want to see the mid steps. And so to do this, we can use the option draw style equals to mid steps. So in our previous plots here, so this is initially how our plot was looking, but if you add the draw style, the draw style equals to mid steps, we can just add for one and you see the difference. You actually do get the difference in your plots, and you can see it's no longer straight as it was, and you can actually see the steps. You can actually see like steps of how the data is progressing, and it does not interpolate and draw the straight lines as it was. So a very good example would be in the max. As you can see, for the max, initially it just interpolated and drew a straight line, and here you can add you can add the steps mid option to actually see the different points. So you can see what is happening. And the same thing would happen if you add to the third axis, and if you remove them, it would still interpolate and draw straight lines as it was in the beginning. So if you misspell the name of anything, you get an error. So you can see that for my case, I did it in my old visualization. You can create a new cell and have the first cell without the draw style option and the next cell with the draw style option. So you can also make your own plot using the standard deviation, and I'd let you do this on your own and visualize the plot, because it's the same concept it uses. It's the same concept it uses when you are drawing the mean, the max, and the minimum, maximum, and mean. So if you are trying to actually moving around your plots, you want to swap the layout of your plots, and you want it to, instead of being horizontally arranged, where we have the first plot, the second plot, and the third plot in a horizontal manner, you want to have your plots in a vertical manner. The first plot, then the second plot below it, then the third plot below it. So to do this, we would go back to our same code, and we'd need to adjust some few things. So the first thing we need to adjust is our fig size. So we need to interchange these two. We had it as 10.0 and 3. So if we want it in a vertical order, we will just do 3.0 and 10. And the next thing to interchange is our axes in the add subplot. So where we had the first row, we had it specifying the rows, the column, and the position. So here we had 1 row, 3 columns, and at position 1. If we want it the other way around, we now need to change this and have first 3 rows, 1 column, and at position 1, 3 rows, 1 column, and at position 2, 3 rows, 1 column, and at position 3. So when you run this code this way, it would actually, initially we saw it printing out like this. Now you can see it has printed out. It has printed it out in a vertical manner. So if you want to interchange the positions, the key things to note is your fig size. Make sure your fig size is in a way the orientation you want it to be shaped can accommodate. And also in your subplots, make sure you change your row, column, and positions. So I just interchanged it for us to have it in a vertical manner. So that is it. And so from this lesson, the key points we learn is how to use matplotlib, and specifically pyplots in creating visualizations, and just to have a graphical or a visual representation of our data. So in case there is any questions in the lesson before this and this lesson, you can ask me. I'm giving 3 minutes for questions just before we go for our break. Thanks. Anything that was not clear? Anything you're not so sure of how it works? And there is one plot I did not plot, which is this. Please plot it, add it to these 3 plots, and try to fit it so that you can have 4 plots. Adjust the position, the row column, the rows, the columns, and the positions of the plots, and see how it would be. In case you are not able to plot it, you can reach out to me just to see. So axis equals to 0 in the plot signifies it's actually an option of the numpy.min. So when you have axis equals to 0, it gives us the mean at each column. And for the columns is days. So if you want to get the mean for each day, which is the columns, that is why we are using axis equals to 0. But if we want to plot not based on the days, but on the patients, we can change axis equals to 1. Olushola, have I answered your question? Is it clear now? So axis equals to 0, it signifies the parameter of your data in which you would be doing your arithmetic operations on. So if when the axis equals to 0, you are doing it on the columns, so you are getting the mean per column. So your plot would be the mean or the average, the mean per day. So if you want to plot based on the patient data, you change axis to 1. So yes. Any other question, or if there's something still not clear? Okay, with that, we can go for our break and come back at 11 sharp to continue with the other part of the lesson, and Toby will be taking you through that. Thank you.
All right, everybody. Welcome back. If you're back from the break, please let me know in the chat. I'd suggest that you might tell me that you're back by sharing a emoji representing something that you did during the break. But you can also just type back or give a thumbs up or something if you like. I have quickly had to move locations, and I guess the first thing I should say before I start teaching is I'm sorry if you get some background noise during this session. I was originally not expecting to be teaching today, and so I'm still at home, but we're getting some work done on the house at the moment, and there are people pulling tiles off our roof. It's making a lot of noise. So I've moved to what I hope will be a quieter place in the house, and I should be able to teach you uninterrupted from here. But if you do hear any banging and other noises, also children perhaps running around and making noise, then I'm sorry for that, but hopefully it won't be too distracting. So thanks to Kautar, who this morning has already talked you through some cool methods for visualizing tabular data with Python. I'm going to talk you through now a sort of another fundamental element, I suppose, of working with data in Python, which is how to store things in lists, and then we will move on in the next section to talk about how to use lists like that to kind of loop through and perform repetitive operations, which we'll be able to draw some parallels between how we do that in Python and why we do that in Python, I suppose, with the for looping that Marie, I think, showed you in the shell lesson earlier in this workshop, and when she was talking you through how to write for loops in Bash. All right, good to see that some folks were getting something to drink or something to eat during the break. I hope that in the next 45 minutes or so, I'll be able to show you how you can store multiple values together in an object and why you might want to do that. And by the end, you should be able to explain to other people what a list is in Python, create and work with those lists, add additional values to them, reorder them, take slices of those lists, so kind of subsets of the values that are in there, things like that. And I suppose to motivate this a little bit based on what you saw previously, you probably noticed, if you're used to looking at data anyway, you probably noticed when you were visualizing that inflammation data that the shape of that line plot of inflammation values seemed perhaps a little suspicious. I don't know, this kind of almost straight line up to a maximum point and then a similarly straight line back down again, like with the peak being directly in the middle. That's not it's not what we might expect to see, I suppose, in kind of biological kind of or biomedical data, like observations of inflammation. And so what we're going to start doing here is looking at a bunch more files of similar data and plotting out what those inflammation values look like across all of those files or multiple files, to see whether this kind of suspicious looking trend is also represented in those other data files. But before we jump into actually looking at those data files, I need to tell you a little bit about this kind of fundamental data object in Python called a list. So up until now, you've been using NumPy arrays. You probably remember that we were importing NumPy, and then we were able to work with an array like a underscore. Oh, that's funny. A underscore NumPy underscore array, equals numpy dot array, and then some values. And then we can have a look at that array like this. We see we get this array 1, 2, 3, or if we print this. So what I'm going to do, because this is quite a long variable name that I've defined, a underscore numpy underscore array, I'm going to start typing it, and then I'm going to hit the tab key. You learned about this in the shell lesson, at least, this idea of using tab completion to complete names of commands and names of files and things like that. You can do the same thing if you're working in a Jupyter notebook like this, or any kind of interactive Python prompt. If you start typing the name of a variable or the name of a library like NumPy that you've imported already, then press tab, then the system will complete the rest of the name for you like it just did there. I'm going to try not to use this tab completion very much while I'm teaching, because I want to go slowly enough that you can all follow along with what I'm typing and try to type it in and execute it as well. But I do really recommend that you get into the habit of using this tab completion, because as we've seen all throughout the workshop up until this point, one of the main kind of sources of errors, I suppose, when we're working with such systems like Bash or Python that are very sensitive to how things are spelt and whether letters are uppercase or lowercase and so on. One of the best ways to avoid making those kinds of typing mistakes is by using this tab completion, because if things are auto-completed, then you don't need to worry about there being errors in that. So let's print out this NumPy array. Okay, it looks like this, 1, 2, 3. But this thing in square brackets that I used to define the values for this NumPy array, so the values 1, 2, 3, these square brackets with those numbers in between, that's something called a list. And so let's define another list, and to help me further stress the syntax, I suppose, for defining lists, we're going to create a list that contains the first 4 odd numbers starting from 0. So the first odd number is 3, and then we put is 1, sorry, and then we put a comma, and then 3, and then another comma, 5, another comma, and 7. I'm including spaces after the commas. These aren't technically necessary. This is also valid syntax, but I find that these spaces after the commas make things a little easier to read, so I prefer to include them. And so this is a list now. It's going to be a variable called odds, and it's going to carry this value around with it, which is this list of 4 numbers. And we'll print, let's put a string first. So odds are, then a colon, close that string, and then a comma and a space, and we'll type the name of our list variable that we just created. So odds are, comma, odds, and then run this cell. And so we're defining this variable odds, and then we're including it in this print statement, and you see that it gets printed out looking very similar to how I defined it in the first place. And one of the things that I think it's worth pointing out here is that lists are printed differently by Python from an array. You see with the array, you don't get commas between the entries, you only get spaces between them. Whereas with a list, when you print it out, you see the commas between them as well. And this is to do with how arrays are often used in NumPy as kind of matrices and for mathematical matrix operations. And if you're working in math, then you'll be used to seeing matrices displayed in this way with the values, but not with commas between them, only with spaces between them. So that's why arrays get printed like this, but our lists get printed with the commas between them. All right. Just like we could do with the arrays before, we can access individual elements of the list using these indices or indexing of the array. And those indexes, just like with the arrays, they start from 0. So if we want to get the first entry in the odds list, for example, then we would put odds and then open some square brackets, put 0 and close the square brackets. And with this, we're saying, please give me the first entry in this list called odds. And so the answer that we see here, or the output that we get here, is 1, because that's our first value in this odds list. If we want to get the last value, then if this is 0, then this is 1, 2, 3. So the last value would be odds 3, which gives us 7. But what's much more common to do if you want the last value is to use negative indexing. It works as well. So odds -1 will give us the last entry in the list. And the reason why it's much more common to use this -1 approach is because that's going to work to get you the last entry in the list without you needing to know how long that list is. So if you know that you always want the last entry in the list, no matter what its length is, then using -1 is very helpful here. Similarly, if you want the penultimate item in the list, so the 1 from last, then you put -2 instead of -1, and so on. I find it a little bit confusing that you get the first entry in a list by putting 0, but you don't get the last entry in the list by putting -0. But I suppose that's because -0 is sort of meaningless. So we use -1 instead. Okay, and so you might have seen this kind of indexing already with strings as well. So so you saw if we create an example string, so an example string equals what should we use? What day is it today? It's Wednesday, right? So let's use Wednesday as our example string. We can also use indexing like this to pull out the individual elements of a string as well. So we can say an example string 0 gives us the uppercase W at the beginning of Wednesday, and an example string -1 will give us the Y at the end. There we go. But there's a really important difference between lists, which contain multiple elements, and strings, which also contain multiple elements. In the case of strings, those multiple elements are individual characters that are treated as a kind of collection together. One of the crucial differences between lists and string, probably the most important one, is that you can change the entries in a list, and you can't change the individual entries in a string. If you want to change one of the characters in one of the positions in the string, you have to overwrite the entire string to do that. I'm going to show you what I mean now. So if we want to change the last entry of the odds list to be 9 instead of 7, then we can say odds -1. So this is us referring to that last entry in the odds list. And then we're assigning a new value with equals here. The value that we're assigning is 9. If we run that and then have a look at the odds, the value of the odds variable, we see that now it is 1359 instead of 1357. If we try to change the last, an example string -1 equals, so instead of saying Wednesday, should we say Wednesdag? So try to change the Y at the end to be a G. If we try to run this, then we get an error message, and this tells us type error, str, so that's short for string object, does not support item assignment. So that's telling us it's not possible to assign a value to a specific position in a string that already exists. Instead, we would need to say an example string equals when stag. If we wanted to do this, we'd have to overwrite the entire string and effectively redefine the variable itself with that new value. Okay, just proving that runs without error. At this point, I'm going to pause for a couple of things. The first thing that I'm going to pause for is to talk you through this error message a little bit more. You've probably noticed already that getting error messages is kind of common. We encounter errors pretty often. And I guess one of the most important things for you to learn in this workshop is that trying things out and getting errors and then reading that error message and fixing the error based on information that it gives you, and then carrying on until you get to the next error and repeating that process. That's like a extremely common pattern in programming, in writing Python or Bash or anything else. We are encountering errors very often, and we're making mistakes pretty often as well. So if you found that while you're working through this lesson with us or in this workshop with us, that you are making mistakes and getting error messages and needing to fix those, I want to try to reassure you that that is what is happening to all of us all the time. I've been writing Python code more or less for about 10 or 11 years now, and I still make lots of mistakes and I still run into a lot of errors. In fact, if I write more than maybe 5 lines of Python at once, I pretty much expect that when I run it, I'll receive some kind of error. And if I write 10 lines at a time and I run it and I don't receive any errors, honestly, I'm a little bit suspicious, because it's so unusual to go through that process and not encounter any errors. So please, if you find that you do run into errors like this quite often, please don't be discouraged. I guess it's a really important part of the learning process, and it's also how everyone is doing things all the time, is running into errors and trying to fix them and looking up online how to fix those errors and things like that. We don't. I suppose there are people out there who have many years of in-depth programming experience who don't run into errors as often as I do, but certainly speaking for myself, this process of encountering errors and fixing them is normal, I guess, is expected. Okay, and having said that, I want to talk you through a little bit the anatomy of this error message output that you get from Python. So Python error messages, they can be pretty long. You might have noticed in the previous session when you were working with NumPy and Matplotlib that the error messages that were coming were pretty long. Whereas in this case, when I tried to do this thing that's not allowed with a string, the error output that I got was fairly short, like 7 lines or something. But the structure of the error message is similar, regardless of whether it's long or short. You always start with this line of like hyphens or minus signs, just to show where the beginning of the error message is. And then you see right under that, this here says type error. This will vary depending on what kind of error you're encountering, but it's telling you, broadly speaking, what category of error you're encountering. A type error is a problem with some problem with type of the object that you're working with. You'll see value errors where Python thinks that the problem is with the value that a variable is carrying and what you're trying to do with that value. You might see syntax errors where you've mistyped well, we'll encounter for loops in the next session, so maybe I'll probably make a mistake while I'm doing that, and you'll see a syntax error there. And there's a bunch of other kinds of errors as well. It's broadly trying to tell you what category of error you've encountered. Then you'll always see this text that says traceback, most recent call last. And then after that, you'll get one or more blocks that looks like this. And I say one or more because when you encounter one of those really long error messages, that's most of that length really is accounted for by this, what's called the traceback section of the error. And that's trying to tell you where specifically in the code you've written, the error is actually being encountered. And when you're working with a large library like Matplotlib or NumPy, for example, then actually for Python to show you all the details of where the error was encountered, it's got to show you where each of the lines of code was called in different places throughout the library. So these libraries of Python code like Matplotlib, they generally involve like lots of different files of Python code where some lines of one of those files are referring to code that's defined in another file in the library, and that code in that file is itself referring to code that's written in yet another file in the library, and so on and so on. And so when you make a mistake or encounter an error, Python will show you where in your code that error was encountered, but then it will also show you how that kind of had a knock-on effect to other lines of code written into the NumPy library or the Matplotlib library encountering an error as well. And you end up seeing like this full, what's referred to as a traceback of everything that's gone wrong in all of these different files on your system. The important thing for you to look at when you've got a long traceback like that is still going to be the very first position that it's telling you about, and hopefully we'll see a longer one of these maybe in the next session or something, so I can refer back to it again. And that's because of this part here that says most recent call last. So the first thing that Python tries to do is run the line that you wrote, and then if that line that you wrote involves it trying to run something that's in NumPy, and then that involves it trying to run something that's somewhere else in NumPy, and so on, the thing that it tries to run first is still the line that you wrote. And so because it says here that the traceback will be ordered with the most recent call last, that means that the first thing that it tried to run will be your line. And so what you can usually do when you see one of these really long tracebacks is still look at the very first piece of location information in the error message, and then scroll through all of the rest of them, because that's all internal stuff that's happening in NumPy or Matplotlib or whatever, and you don't need to worry about it. What you usually need to worry about is what you've written in your code, and that's always going to be the part that's at the top, immediately underneath this this part of the error message that tells you what category of error you're working with. And so then let's have a look at that location information. It's telling me cell 14. So that's referring to this number in the square brackets here in the Jupyter space. And it's telling me line 1. Well, there's only one line in the cell, so of course it's on line 1. But if we had a cell with multiple lines, like I think we did up here, this would be line 1 and this would be line 2. And so if the error was on this line, then we'd have seen it's a line 2 here instead of line 1. And then we get this little arrow pointed here to the line itself, telling me that this is where the error is. And sometimes Python's able to be more specific than only telling you this error is on this line. It will even be able to try to point out to you exactly where the error is occurring in that line. And in those cases, what you'll see is another little arrow somewhere underneath the line pointing to the exact position in the line where it thinks the error is. So Python's trying to be helpful here by providing you with a bit more information about exactly where this error is that you're encountering. And then, like I said, even if the traceback is really, really long, in this case, it's not, it's very short, but if it was really, really long, you could still scroll through the entire thing until you get to what I think is the most helpful piece of the error message, which is the message itself that tries to describe what's actually going wrong in the error. And I read this right at the beginning when I was explaining what had gone wrong, but let's read it again. So it says type error again, just kind of reiterating the category of error that's being encountered. And then this is the error message itself. So string object does not support item assignment. So this is some feedback that Python is trying to give you to describe the nature of the problem. So here it's telling us that we're trying to do something that's not allowed with this string object. Okay, so that's probably quite a lot of information, and I may have talked quickly through it. So I'll pause here and ask what questions you have about, I guess, lists and the indexing and assignment that we've done up until now in this session, and also if you have any questions about, or what questions you have about error messages and how to read them in Python. All right, silence. We'll take silence to be a good thing in this case. But if you do find that something's unclear or you're confused about something, then please type into the chat, unmute and ask a question. Whatever you'd like to do, just please communicate with me if something's unclear so that I can go back over things again. All right. So I guess briefly, let's make this a markdown cell, and we'll say about this difference between lists and strings. I think I hope it's helpful for you all to know the technical terms for this, so that in future, if you want to look for help online, you want to ask somebody else for help with this kind of thing, then you'll know the half the battle with searching for help with programming online is knowing the terminology, so you know what to type into the search engine to be able to find the advice and the help that you need. So I'm going to write here that lists are mutable. This means they can be edited after they were first created, and strings are immutable. This means that their value is fixed after they have been created, and the only way to change their value is to explicitly overwrite them. Cool. Oh, okay. Let's make that bullet point. So yes, so that it appears a little more line by line, like I wanted to. I don't think it's the most useful way to spend the time now to go more deeply into the difference between mutability and immutability of objects. The most important thing for you to know right now is that lists can be changed after they've been created. You can build them up, you can trim them down, and so on as you go through, whereas strings can't. Let's talk about lists of lists, because you already saw a two-dimensional array, or a two-dimensional array, I think. You can also create sort of an equivalent with lists, which would be a list of lists. So we usually call that a nested list. I'll show you an example here. So we might create a nested list of, now I'll tell you what I'm going to do is share the image, I think, share the lesson itself rather than type all of this out, because I think it only makes sense if you're looking at the visual anyway. So scroll down, here we go. So nested lists, as it says here, a list can contain any type of variable. So far, we've only shown lists. I have only shown you lists that contain these integer values, 1, 3, 5, 9, and so on. But really, a list can contain whatever types of data you like in the different positions. So that means you could have a list that contains integers and strings and floating point numbers and so on. You can also have a list that contains individual lists, and that is where you end up with this thing that we refer to as a nested list. So here, for example, we're showing you how you might represent the products that are on the shelves of a grocery store in a nested list that we'd call veg. So we define this veg list object with this value, right? So we're opening the list with a square bracket here and closing it with a square bracket here, and it's got 3 entries. This is the first entry in that list, and then we've got the comma here separating that from the second entry, which is this one, and then another comma separating that one from the third entry, which is this one. And each of those entries is itself a list with 4 values, and each of those values is a string. And so those are separated by these commas as well. So we've got lettuce, different kind of lettuce by the looks of things, they're peppers, zucchini, and so on, with apologies to the folks who refer to these vegetables by different words. This is how they're written into the lesson. I think one of the most important things to show here, and I'm going to copy and paste this because it's an awful lot of typing out, and very likely that I'll make typos that will be time consuming to fix. So let's paste this into the notebook. I think the important things to point out here are the double square brackets, right? So this is the opening and closing square brackets of the veg list, and then this is the opening and closing brackets of the individual lists that are contained within that nested list called the veg. When you click your mouse or move your cursor to be next to the right specifically of one of these square brackets, it gets highlighted in this kind of brighter green color. And you'll notice, I hope, that the closing square bracket associated with this opening one also gets highlighted in green. So if I move my cursor 1 to the left so that I'm now positioned to the right of this opening square bracket, you'll see that it's this closing square bracket down here that gets highlighted in this brighter green as well. And that's a way that the Jupyter interface is trying to help you more quickly visually identify which pairs of brackets belong together, because it can get very confusing very quickly to try to read code that's got a lot of these kinds of square brackets next to each other and nested together. Another thing that we can do when we're writing this code to make it a bit easier to read off the screen is split this nested list across multiple lines. That's what's being done here. And I'm going to add a few more spaces to line things up a little better. By doing this, so we put our comma after the first list, and then we press enter. We can add as many spaces as we like before putting the second entry, which is this one, and then we can do the same thing. And this kind of breaks up this long line defining this big nested list, and makes it much easier to read than if everything was on the same line like this, because then you got to kind of scroll along to really take a look at it all. One of the nice things about the Jupyter interface is that if we want to split a nested list definition like this across multiple lines, then when we press enter the first time to add this first line break, Jupyter will automatically insert these space characters at the beginning of the line to set the indentation to the most readable level. And so when I press enter here as well, then we get the same effect. And so we can run this, and that's valid syntax to have this split across multiple lines. And very similarly to the indexing that we saw with a multi-dimensional array, if you want to access a particular entry in a nested list, then you would use multiple indexes. However, the difference is that where with a array, with a like two-dimensional array, you could put, let's say you wanted to get the second entry in the third list here. If it were an array, you might have put 2 to get to the third list, and then 1 to get to the second entry. If we try to run that, we can't define the indexes like this for a nested list. Instead, we have to do 2 indexing operations. So the first one would be to get the third entry in the veg list. That's this one here. And then we put in immediately afterwards another set of square brackets with the 1 in between. When we run that, we get cilantro, which is this second entry in the third list. So what's happening here is you can read this from left to right, and each block kind of gets evaluated before the next one does. So first, what Python does is it evaluates veg2, and this would get replaced effectively by the output of that operation. So in this case, the third entry in the veg list, and then this second indexing operation gets applied to the output of that first one, which is why we then get the second entry in that third list. What questions do you have about this kind of double indexing operation that I've just performed? Okay, so then I'm going to ask you a question, and you can type this into the chat if you like. If I didn't know how many lists there were in this veg variable, and I didn't know how long those lists were that are contained within it, how could I get the last entry in the last list in this nested list object? Can someone type the answer into the chat, please? So the question is, how could I access the last entry in the last list in a nested list object, even if I didn't know how many lists or entries it contained? Can anyone answer that question for me? Great, thank you, Charlene. Thank you, Leonard. Exactly. So we use this -1 approach to refer to the last object, and we can use that twice in this case. So we could say veg, where am I typing? Veg -1 to refer to the last entry in that veg nested list object, and then -1 again to refer to the last entry within that last entry. And there we see zucchini. So that's this value in this case. All right, thanks everybody. So as well as overwriting, but you'll remember when we created this odds object, hopefully you'll remember that it had the values 1, 3, 5, and 7. And then we replaced explicitly the last value with 9 instead, and so now it's got this value 1, 3, 5, 9. But there are a bunch of other ways that you can modify the contents of the list as well. So for example, you can add another value onto the end. So you could say odds dot append. And so what we're doing here is we're calling what's called the append method of this odds object. And inside these parentheses here, after the name of this method, we provide the value that we want to append to this list. And append means add this value at the end of the list. So let's append the value 11. Run that. We get no output at all, but we can check whether or not it worked. And we assume that it did because we also didn't get any errors. And so usually no news is good news when it comes to programming. If you don't get any output at all, it's usually a sign that things worked. Let's take a look at odds now, and we can see that it's become one value longer, and that value is 11. What we told Python to append. Similarly, we can remove entries in specific positions with another method called pop. So we'd say odds dot pop 0. And what that's going to do is it's going to remove the first entry in this, so the entry at position 0 in this list, and it's going to actually return that value to us. So we could capture this in a variable. I'll show you in a moment. So let's run this. We get the output 1, and then if we look at odds, then we've got 3, 5, 9, 11, and that 1 from the beginning is gone. And like I said, we can actually capture that if we want to. So we could say removed element equals odds dot pop 0. And we get no output now, but if we look at this removed element variable, we can see that it has the value 3. And if we look at the odds variable, we can see now that there's only 3 entries in there, and the 1 and 3 have both been removed. Another thing you can do to modify a list in place is you can reverse its order. So we can say odds dot reverse, run that, and then take a look at odds. And now it's 11, 9, 5 instead of 5, 9, 11. And there's a bunch more that kinds of operations that you can do as well. And I think here it's a good idea to pause and talk about another kind of general thing with Python that I think we've only been, you might have inferred by now, but we haven't talked about it directly. And that's this really common pattern that we see in Python, where we refer to the name of a particular variable, a particular object, and then we type dot, and then we type something else afterwards, and we might have these parentheses after that, or we might not. In the case of the NumPy arrays that you were working with in the previous session with Kautar, you were asking for the shape of that data with data.shape, and that didn't have these parentheses afterwards. That's what's referred to as an attribute. So it's like a piece of information about an object, but it doesn't do anything except tell you that information. So in this case, the shape of the object. Whereas reverse here, or pop up here, or append, which I used before, these are all what are referred to as methods of this object. And methods are like pieces of functionality that the object carries around with it. They're usually operations that you would commonly want to perform on data of that particular type. And you, what's referred to as call those, you execute those operations by providing these parentheses afterwards. And sometimes you need to provide information in those parentheses, like pop will expect you to tell it what position you want to remove from the list, whereas reverse doesn't expect any information. You just provide the parentheses with nothing in them and then run the code, and it will reverse the list. And you'll see, you know, I've been doing these examples with lists, but you'll see this kind of pattern where you have the name of a variable and then a dot and then some method name. You'll see this really often in Python. It's an extremely common pattern in Python. To give you another example, I think I defined an example string earlier, and so example strings have, string objects have a method called upper, and if you run that method on a string, then what you get is a all uppercase version of that string. And similarly, you can run an example string dot lower and get an all lowercase version of the string instead. If you want to know what methods are available for an object you're working with, then you can type the name of the object and then the dot, like you're about to start typing the method, and then you can press the tab key. And what you'll see is this nice pop-up appears that tells you you can append, you can clear. I've never used clear before, but I'm going to guess that what that does is it empties the list altogether. Copy to create a complete copy of the list. Count, I think, tells you the number of times that a particular entry appears in that list. I think extend, you can provide a second list in the parentheses and you'll get a list that is the two lists combined together, but I might be wrong about that. Let's find out, I suppose. So I can, with my mouse, I can click on extend here. I can use the up and down arrows to move the highlighting down to extend, and then press enter. And it will automatically fill in extend. And then I can put a question mark at the end of the line and run this cell. And what I get is a little bit of helpful output information. It tells me extend list by appending elements from the iterable. And it tells me this is how you use it, odds.extend, and then in the parentheses, an iterable. An iterable is any kind of object in Python that contains multiple values. And so I think do odds.extend and then provide another list in the parentheses here. And what are some other odd numbers? We'll do 23, 29, and 87. Run that, and then let's take a look at odds now. And sure enough, we've got 11, 9, 5, our reversed order entries from before, and then after that, 23, 29, and 87. Okay. I think the last thing that I want to tell you about this is you might have noticed that there was this copy function, and as I mentioned, what that does is it provides you with a copy of the list. This is important because if we let's recreate our odds list now with only 3, 5, and 7 as the values in it. Check that that's worked. Yep. And then I can point out that these are also prime numbers. 3, 5, and 7 are all prime numbers. So we might also want to start carrying another list of prime numbers, and we might start that off by thinking, well, we've already got this list called odds that contains prime numbers, so why don't we create this new list primes that has all the same values as odds, and then we could do that by saying primes equals odds. Let's have a look at primes now, and sure enough, it says 3, 5, 7. Now, if I add some more prime numbers or add another prime number to this primes list, so 2, for example, is a prime number, but it is not a odd number. I run that. Let's have a look at primes. Cool, we've got the 2 on the end, as we would expect from appending 2 there. But now if I take a look at the odds list as well, you'll see that the 2 has also been added there. And this is it's a quirk, I suppose, of Python, but it's important for me to tell you about it now, because if you're not aware of this kind of behavior of Python, then you can encounter really confusing behavior. So I think it's worth us talking about here and now. Effectively, what's happening is on this line that we ran here. What Python does by default when you perform an operation like this is it doesn't create an entire new object called primes that contains all the same values as the odds object. Instead, it creates two labels on the same piece of data in the computer's memory. So that piece of data then has the label odds associated with it and the label primes associated with it. And then when we perform this operation on one of those labels, that performs the operation on that piece of data in the computer's memory, and both labels get kind of updated with that new value. So instead, it's a good idea to create a complete copy of the list instead, and I'm going to show you a couple of ways that you can do that. Excuse me, I just need to drink some water. Okay, that's better. So one of the ways that you can, well, okay, no, I'll talk about creating a copy in a moment. I think before that, let's talk about subsetting lists, taking slices of lists. So I think you saw this with arrays already, but where am I typing here? We can get a subset of a list by specifying in square brackets instead of a single position like we were doing with 0 before. We could specify a range like this. So we inside the square brackets, we provide the starting position that we want to get a slice from, then we put a colon symbol, and then the ending position that we want to take. So look at this. And so what we get here when we're taking a slice like this is we get this slice starting from the starting position that we provided here and then ending one before the ending position. So 2 refers to the third entry in the list, but we don't actually get that third entry. The slice effectively, it starts from the left. It starts to the left of the starting position that we define and stops at the left of the ending position we define. So we get kind of this first half instead of the entire thing. That again is it's a idiosyncrasy, I suppose, of Python. It can be a little bit confusing to remember that you always get everything up to but not including that ending position. You're gonna have to get used to remembering that, I suppose. But we can also say if we want to start from the beginning, we don't actually need to include the 0 here, like we were doing before. So I can delete that and have nothing here and just the colon and then the 2 and get the same result. If we leave the starting index out, then the default behavior is to start from the beginning. And similarly, if we include a starting position, let's say 2 again, but we leave out the ending position, then we'll always go up to the end of the list. And this works as well on strings. So here's my example string again. And let's start from the 5th position and go right up to the end of the string. We get sdag. And if you want to, then you could also leave both sides out of the colon. So like this. So this would then be interpreted as start from the very beginning and go to the very end. And so actually we just get the entirety of the odds list. And we can use this actually to create a complete independent copy of the list. So let's go back to defining our list of primes again, 3, 5, and 7. But this time, when we want to create the prime numbers, we'll take those odds and make a copy like this. So saying start from the very beginning and run to the very end. And then we can look at primes, make sure that we've got it as we thought. We can append the number 2 to it again, like we did before. And now let's look at odds to see if that's also had the number 2 appended to it. And you can see that it hasn't in this case. And that's because when we performed that copying operation, we used this indexing starting from the very beginning and running to the very end. And this kind of explicitly told Python, I want to create a complete copy of this list instead of referring directly to that list in memory like we were doing before. What this means is your program takes up twice as much memory because it's got 2 copies of this list now being stored in memory, but at least they're independent and you can treat them independently without worrying about this kind of crossover behavior between the 2. That all might have seemed a little theoretical, in which case I guess I'm sorry, but it's I feel like it's an important thing for us to talk about when you're first learning Python, precisely because if you're not aware of it, then when you do encounter this behavior, it's going to be really confusing because it's a completely non-obvious thing that Python is just kind of doing in order to manage the memory of the program behind the scenes, so to speak. What questions do you have about that last part that I just went through? All right, so once again, I will take your silence to be a good sign. Let's look at what I think the last thing that I want to do is look at how different operations behave differently on lists compared to arrays, because one of the things that might not be very clear right now is why you would want to use NumPy arrays rather than lists, or why you would want to use lists rather than NumPy arrays, and why we were using NumPy arrays to load in our data before. And to do that, we need to talk about the different behaviors that you can get from kind of standard operations in Python. So we've got, I think, I've got these 3 variables. I've got print these out. So print a NumPy array. Oh, got an E on the end. Print. Let's remove that. Print an example string and print primes, I suppose. So I've got my array with 3 entries, 1, 2, and 3. I've got my example string, which is Wednesday spelt wrong with a G at the end. And I've got this primes list with the values 3, 5, 7, and 2. And to show you the different behaviors of standard operations, I'm going to show you what happens. Let's copy this, make a complete copy of this cell. I'm going to show you what happens if I multiply each of these example variables that I've been creating by 2. So to multiply in Python, we use the asterisk symbol. So in each case, I'm taking this example variable of a different type. We're multiplying the array by 2. We're multiplying the example string by 2. And we're multiplying this primes list by 2. And I'm going to run this, and we'll look at the output that you get each time. Because each of these is kind of subtly, but really importantly different. What has happened when we multiplied the array by 2 is that each of the elements within that array has had its value multiplied by 2. So 1 became 2, 2 became 4, 3 became 6, right? With the string and the list, we've had all the values that were contained within those objects doubled and effectively kind of stuck together one after the other. So we've got Wednesdag for the string, and we've got 3572, 3572 for the list. So both the string and the list have become twice as long. And in particular, I suppose the thing that I think it's really important to stress here is that, so I'm going to put this in Markdown because I think it's so important. The key thing to think about when defining variables is which type of variable will be most useful for your purposes. For example, if you are likely to want to perform mathematical operations on a large set of numeric values, a NumPy array will probably be more helpful than a list. The reason for that is that NumPy arrays are set up to perform these kinds of mathematical operations element-wise, so element by element, applying the same operation to each of those elements in turn, rather than treating the operation as an operation on the array object as a whole, which is what's happening with the list. The multiplication is being done to the list rather than to the individual elements of the list. And I'll show you, I guess, in the next section when we talk about for loops, what you would need to do, what you would need to write to actually multiply each of the elements in the list by 2 to do the equivalent to what happens on this line with the elements in the array. But suffice to say, it's like two or more lines of code than is needed for the NumPy array, and it will also, in terms of the performance of your program, it will take longer and it will require more memory to perform this kind of operation on the elements of the list than it does on the NumPy array, and that's because of the way that NumPy arrays have been designed to be explicitly expecting this kind of operation to be performed on them pretty often. Okay, I think it's time to take another break before I run into the next section, which will be the last one for today. Before we take the, actually no, after we take the break. So let's break for 7 minutes and come back at, so break until 12:10 South African Standard Time. And then there will be time for questions when we return. So when we get back at 10 past, if you've come up with any questions during the break, then I'll be very happy to answer them. But otherwise, or regardless, I'll see you back here in 6 minutes now. So just a short break. Thanks, everybody. All right, folks, just a short break, and now we're back. For this last section, which I think will be relatively short, but then I'm going to give you an exercise to do. We're going to talk about looping in Python. So to remind you what you saw this morning, with Kautar talking about visualizing tabular data, you wrote some Python code for plotting out those values from the information data set. And I mentioned when I kicked off just before that we were going to start working with a bunch more data files rather than just the one that we'd been plotting with up until now. And so I had to show you lists because, as we're going to find out when we want to start working with those like multiple files of data, we're going to need to store the names of those files in a list to be able to refer to them one at a time. And then now I need to tell you about how to use looping to be able to perform the same operation on multiple values. In the case of our information data and plotting things out, that's because what we will want to do is perform the same kind of analysis, the same plotting operations on each of those files, one after the other. And so, as well as being able to store the file names in a list, we need to know how to loop the operations through each of those files. Sorry, just a moment. Sorry, briefly interrupted by a 3-year-old. I think he's gone now. I'm going to carry on going. So yeah, sorry about that. Where was I? Yeah, we saw before I had this odds list. Let's make another one. So 1, 3, 5, and 7 again. And so we could, as we saw, access the first entry with 0. So we could, if we wanted to, perform the same operation on each of the values. Let's say, do you remember I showed you in the previous session, just before the break, this difference in how multiplication applies to the elements within a list compared to with an array. So let's say that now we do want to multiply each of the elements in this odds list by 2. We could say odds 0 equals odds 0 times 2. Run that just to show you that it's working. Let's have a look at odds now. So now 1 has become 2, but we've still got 3, 5, and 7. And if we want to perform this operation on all of these entries, then we'd have to type odds 1 equals odds 1 multiplied by 2, and odds 2 equals odds 2 multiplied by 2. And finally, odds 3 equals odds 3 multiplied by 2. We've done this now, and let's have a look at what odds looks like. 2, 6, 10, and 14. Great. So we did get what we wanted, but it was quite a lot of typing. And if we had, instead of 4 entries in this list, we had 40 or 400, then this would really very quickly become, if not impossible, mind-numbingly boring, and also highly likely that because you'd lose concentration because it's boring, you'd make a mistake. And so it's not very reliable, I suppose, and it certainly isn't very exciting as a method for doing this. And so instead, if we want to perform the same operation on every entry within a list like this, we can write what's referred to as a for loop, and you saw these already in the shell lesson. Okay, can anyone confirm to me that they can hear me, please? Okay, Charlene, you can hear me. That's good. I want to make sure that I haven't just been talking to myself for the last 5 minutes. Okay, thanks everybody. I'm going to keep going. I'll just reply in the chat. Okay, so let's write our first for loop instead to do this. So we'll once again we'll multiply all of these values by 2 again. So we'll end up with a multiplication of 4. Oh yeah, okay. I'm going to follow the example that's in the letter. Instead, let's define a nice long list to prove how helpful this can be. Okay, so now I've got the odd numbers from 1 up to 19. Don't think I missed any. If we want to perform this operation on all of those, then we write our for loop. And you might remember from the bash lesson that the way we wrote the for loop was we wrote the word for, then a space, and then the name of a variable. So we're going to say for number, and then in. But here we're going to refer to the name of the list variable that we want to loop through all of the values of. And then where in bash, I think we type do here. In Python, we put a colon symbol at the end of this line and then press enter. And you will notice, if you're following along with me, that when you add that colon symbol and then press enter, the cursor in Jupyter automatically gets jumped a little bit to the right. This is referred to as indentation. And this indentation is really important in Python. This is how Python knows what exists within the loop and what doesn't. So I'm going to show you in a moment. Let's do print number just to prove what's happening here. So we get 1 per line, each of the values that was within that list. And so what's happening is that this for loop is looping through this list 1 entry at a time. And each time it loops through, it's doing the thing that's defined underneath on the indented line. In this case, it's only printing that out. But we could say, print number times 2 or whatever. And to help make it clear what's happening inside the loop and what's happening outside the loop, let's write another one. So for number in odds, print, and then a string. This happens inside the loop. Print number times 2. And then I'm going to press delete to remove the indentation for this last line. So print this happens outside the loop when there are no elements left to work through. When I run this, what we're going to see is these 2 lines repeated for every element in that list. And then once we've got to the end of that list and there's no more elements to be processed like that, we'll see this line get run. So we see this happens inside the loop 2, this happens inside the loop 6, 10, 14, 18, and so on. And then at the very end of all of that outputs, this happens outside the loop when there are no elements left to work through. And so that's the importance of this indentation here. That's defining, the indentation defines what belongs inside the loop. And then when you remove that indentation and start writing more lines of code, those are operations that will only be performed once the loop has finished working. This, as I think was mentioned in the shell lesson, this number variable, that's referred to as the loop variable. So this is a variable that's created sort of on the fly when loop is run, and it gets handed a new value each time for each iteration through the loop. So each time the loop starts again, this variable gets a new value, and that value gets used in that run through the loop, that iteration through the loop. So we could call it whatever we wanted to. We could say for banana in odds, print banana, and we get the same output as before. You just have to make sure that how you refer to that variable inside your loop matches up with how you defined it when you first started defining the for loop on the first line. However, I don't think that the variable name banana is as helpful in this case as the variable name number, because it's not as descriptive of what information is actually going to be carried by that variable each time you run through the loop. Let me show you one more thing with lists. So do you remember I showed you how shall we do this? Let's have a look at what things there are that you can do with lists, like we were looking at before. We've got append, clear, copy, count, extend, and then there's this one index. Let's run the question mark operation on this in Jupyter to see what this index method does. So it says I should use it like this, odds.index, and then inside the parentheses I should provide a value. I could also provide start, but start's going to have a default value of 0, and I could provide a stop. Stop's going to have a default value of this extremely long number that I'm not going to try to read out. Suffice to say, it's much longer than our odds list is, so I don't think we need to worry about stop. And what it does is it returns the first index of a given value. So, for example, let's remind ourselves of what's in odds. So I could say odds.index, and then one of these values, let's say 13. And what this returns is the index of that value. So I should then, if I put odds 6, get the value 13. And I suppose the other thing that is really important to remember is that this returns the first index of that value. So if there were multiple occurrences of the number 13 in this list, then I would only be given the position of its first appearance within the list. But here, each of the numbers is different, so we don't need to worry about that. And another way of writing this then, and this is a little redundant, I suppose, but it serves as a good example, I think. I could say odds.index 6, and then close the square brackets. And what will happen here is that this part inside the square brackets gets run first. So that gets evaluated and returns this, index 13 rather. This will return that number 6, which is the index of the first appearance of the number 13. And so then we'll run odds 6 and return 13. Of course it will, because we're using the index here that's returned from the indexing method to find out what index 13 is at. So of course we get 13 in this case. But we could use this if we wanted to in a loop by saying for number in odds dot index number, wrong kind of parentheses, there we go, equals number times 2. And what this is going to do is it's a little bit of a confusing line, so I'm going to take a moment to talk you through it, but what happens first is the stuff inside these square brackets gets executed, and so that's running up. I forgot the S, the variable name, odds.index number. So each time we go through the loop, we're going to ask for the index of the number that's been given. And then we're going to use that index to overwrite that value with 2 times the number. And this is a really convoluted way of doing element-wise multiplication by 2 that we saw you could do very quickly with a NumPy array. So we get all of these values doubled now. But it's convoluted, right? Because, well, of course, each time that you run through, what you get returned here is going to be increasing by 1 by definition, because you're looping through the whole list one at a time. To begin with, you're working with the first entry, and of course what's going to be returned by this operation on that first entry is going to be 0, because you reading through this already know that's inevitably going to be the index of the number that you're currently working with, because the for loop starts at the beginning and runs through to the end. So this feels there must be an easier way to do this, right? And it turns out that indeed there is. We can say for number in, and then call a special built-in function in Python called enumerate odds. And then the colon, and enter, and let's print what we get out in this case. And so I'm still using the variable number here, but as we'll see in a moment, that's not exactly what you get. So now we get this kind of strange looking output: 0, 2, 1, 6, 2, 10, 3, 14. But what this actually is that it's pairs of numbers where the first number in each pair is the index, and the second number is the value there. So remember, because we doubled this already. So now the first value is 2, the second value is 6, the third value is 10, and so on. And so what we can do instead is we can say for pair in enumerate odds, print pair 0 to get the first entry. Oops. And then we only get the indexes. If I edit this to also add print pair 1 to get the second entry in each of those pairs as well, then we get 0, 2, 1, 6, 2, 10, 3, 14, and so on. But actually, there's a nicer way to do it than that, which is to say for index, comma, value in enumerate odds, print index, and we get the indexes. Or if I edit this to add another line, print value, then we get the same output as before. But by defining this for loop like this, where we actually define 2 loop variables, in this case, they get past the first and second of the pair of values that gets handed out by this enumerate odds function call. And so we can use this to perform that multiplication operation that we saw before. So index for index value in enumerate odds. We can say odds at index equals value times 2. And this is a, oops, this is run, but we don't see anything. So now let's have a look at odds. And now, sure enough, all of those values have been doubled again. This is still a slightly complicated way of doing it, but the complicatedness of it is sort of the point, because I'm trying to illustrate to you here one of the key things that makes that NumPy array object so helpful is that if you do want to do things like multiply values together on a large set of numbers all at once, then a NumPy array is probably the kind of data, the kind of data structure that you want to store that data in, because it will make performing those kinds of mathematical operations much, much easier. Okay, finally, as well as this enumerate built-in function, I'm going to tell you about len if you haven't seen it already. So len is another built-in function in Python that tells you the length of something. So len odds is 10. There are 10 entries in it. 1, 2, 3, 4, 5, 6, 7, 9, 10. Sure enough. And len also works on anything else that can have multiple elements in it. So as we learned before, that includes strings as well. I got rid of, I'm using a new notebook, so I don't have my example string anymore, but let's create that again, and this time spell it correctly, Wednesday. And then we can ask the length of that example string. So len and example string tells us that this is 9 letters. So if you want to find out how long something is, like a list, for example, then the len function is a very good thing to use for that. And on that note, I will pause to see what questions you have before I set you off with an exercise, and then we can wrap up for the day. So what questions do you have for me about loops or any of the other things that I've just talked through?
Hi, Toby. Sorry, I've got a question. I closed, what you call it, one of those terminals, those black terminals, and my workbook, my Jupyter notebook, is now saying it's not connected. Is it in any way related to me closing that black terminal?
It is, yes. So
how do I reconnect it?
If you close the terminal, then any programs that are running, like commands that are running in that terminal, will automatically get terminated. And so the program that acts as a server for this Jupyter Notebook interface was running in that terminal, and when you closed it, it stopped the server. How can you start it again? Mm-hmm. Open a terminal, open a git bash prompt, and type. I don't know if were you running does your interface look like mine? I mean, now it says not connected, but is the layout, does it look like this with these things on the left and file, edit, view, etc. at the top?
Yeah, I think it does.
Okay, cool. And what you should do is open that new terminal and type Jupyter Lab in, press enter, and wait for Jupyter Lab to launch again. Once it's launched, go back to the window where you've got the pop-up that says that it's not connected, and there should be a button to click that says like reconnect or something, and see if that works.
Okay, let me try that.
Sure. While you're trying that, I'll ask the rest of the group if anyone else has questions, and then we can come back. All right, well, I'm not hearing any more questions. Polite, please speak up if you're still having trouble, and I'm happy to try to help you get set back up again. I've just told you about a couple of built-in functions in Python. We saw the enumerate function and what that does in a loop when it's provided with a list. And I also talked about this other built-in function called len, which tells you the length of an object. It tries to tell you the length of an object regardless of what type that object is, but in some cases, an object of a given type won't have a length, and then you'll see an error. Let's show an example of that actually. So I could ask what the length is of the integer 1. And there we get another one of these type error messages that tells me object of type integer has no length, which seems reasonable. An integer doesn't really have some property that you could really define as a length. So this exercise that I'm going to set you all now is a little bit to do with loops and a little bit to do with built-in functions as well. As it says here, Python has another built-in function that's called range. Let's edit this markdown slightly so this shows up a bit more clearly as a this code, I suppose. So sorry, just going to quickly add some backticks in here and here. There we go. All right, so Python has a built-in function called range that generates a sequence of numbers. Range can accept 1, 2, or 3 parameters. If one parameter is given, range generates a sequence of that length, starting at 0 and incrementing by 1. For example, range 3 produces the numbers 0, 1, and 2. If 2 parameters are given, range starts at the first and ends just before the second, incrementing by 1. For example, range 2, 5 produces 2, 3, 4, so stopping just before it gets to 5. If range is given 3 parameters, it starts at the first one, ends just before the second one, and increments by the third one. For example, range 3, 10, 2 produces 3, 5, 7, 9. So starting from 3, jumping 2 to 5, jumping 2 to 7, jumping 2 to 9, and then stopping because 9 is the last number it can get to before 10, which was defined as the stopping point. So what I would like you to do with this exercise is using range, write a for loop that uses range to, that's a little redundant, to print the first 3 natural numbers. So 1, 2, and 3. So you need to write a loop that results in this output 1, then 2, then 3 using the range function. And I'm going to give you 5 minutes to try to do that, and then I'll come back and talk through a solution, and then we can spend a bit of time wrapping up for the day. If you have any questions or you run into any trouble, then please speak up or type into the chat, and I'll be more than happy to help you. All right, that's been about 5 minutes. Would anyone like to tell me what I should do to write this for loop that will produce this output? Feel free to unmute and tell me what to type, or otherwise type something into the chat.
Okay, we can use a for loop by writing. Hello, can you hear me?
Yes, I can hear you. Please go ahead.
Yeah, we can use a for loop by writing for, let's say, for num in range. So in range 1,4, the 1 indicates where it will start, the 4 indicates that it will stop at 3. Then column, then we print num.
Very good. Excellent. That's exactly right. And yeah, thanks for explaining Y1 and Y4 as well. Cool. Good. I hope that made sense to everybody else on the call as well. I propose that with only 15 minutes left, it's a good opportunity for us to do a bit of check-in. We've still got more Python to come tomorrow. And I want to make sure that these sessions are as useful for you as possible. And then after we've covered a bit more Python tomorrow, we'll move on to talk about version control with Git and GitHub in the last lesson, I guess, of this workshop. So what I've done is I've created a little section for feedback on the Etherpad. So that's from line 155. And what I'd like you to do is head over to that document now. I've just put the link into the Zoom chat. And you please do this anonymously. But I'm asking three questions there. So first of all, please tell us how useful the Python sessions have been for you so far. Please tell us how confident you're feeling about being able to use Python in your work after you leave the workshop. And then please also take a bit of time to think about what questions you have about Python and how you can use it that you hope we'll be able to answer before the end of the session tomorrow. So I'm going to give you a bit of time to add your responses there. Please be honest, because the more honest you can be in this feedback, the more useful it is for us as instructors to be able to continue to help you get the most out of this workshop in the remaining time. And then depending on what questions come up, if there's any questions that I feel I can answer quickly enough to cover them today, I'll do that. But otherwise, I'll make sure that we're prepared to try to answer them tomorrow. All right, thanks to those of you who've provided feedback already and written questions. For those of you who haven't, or perhaps who are watching this recording back at the end of the day, head to the Etherpad, please, and provide that feedback and write your questions in so that we've got a list of them for when we start the session tomorrow. It's getting quite loud here. The folks doing the work on the roof have started drilling something by the sounds of it. So I'm sorry if you're not able to hear me clearly for this last part. One of the questions that's come in, so there's two questions on the Etherpad at the moment. The first is about how to know what functions are out there, what options there are, and how to also be able to kind of evaluate which one is the right one to use in different circumstances. I think that's something that I'd like us to talk about in more detail tomorrow. We can talk through a few strategies, I guess, for finding that kind of thing out. The second question is about how to slice through each word of a string rather than each character. And that is a thing that I think that we can talk about now because we've got 10 minutes left before the end of the session. So I'm going to demonstrate that now. So make a title quickly here. So splitting up strings word by word. Cool. So let's create an example sentence. I've forgotten to put the underscores in. That's kind of a long variable name. We'll just call this variable sentence. We'll say, what's a good sentence? We'll do, this is the tail of a tiny snail, a great big grey humpback whale, because that's the first sentence of a book that I like to read to my kids. Okay, so we created this variable and it's called sentence, and it's got a bunch of words in it. And so the question was, let's say that we want to get the third word in this instead of the third character. You'll remember, I hope, that you can get the third character in a, no, I had it right the first time. The third character in a string by using this indexing, and it starts from 0. So 0 is the first, 1 is the second, and 2 is the third. This gives us the third character. But how do we get the third word instead? Well, let's have a look at what methods are available for a string. So you saw that I was doing this with lists before. I type out the name of my string variable, and then I want to find out what things are kind of built into that I can do with it. I type dot and then press tab, and we get this pop-up that appears showing all the different things we can do. And I showed you there's an upper method that converts it all to uppercase. There's a lower method that converts it all to lowercase, and so on. And let's have a look through here, because I believe if I scroll down to the S, I can also, I'm fairly confident it starts with S, so I'm going to type S. That filters this list of all of the things that are available to only include the ones that include S, and it starts off by showing me the ones that begin with S. And you see there's this one called split. Let's have a look at the help message for that split method. It says, return a list of words in the string using set as the delimiter string. So this is exactly what we want to do. Delimiter is a technical term that means the character that will define the division between one thing and the next thing. So if we're talking about words, then usually that's space, right? So we would say so we would say sentence equals, sorry, not sentence equals, sentence dot split. And then we can read a bit more of this documentation. You can see that the default value for set is none. And then if we read here, it says the delimiter according which to split string. None, the default value means split according to any white space. Discard empty strings for the result. So white space here means space characters, but it also means tab characters. I think it probably means new line characters as well. So anything that's kind of blank space between letters or other characters that you would normally read. So that means that we can split, we can run this split method without any additional information, because we can use this default value of none, and we probably get what we want. Let's give it a go. So what we get is this list. We can tell it's a list because it starts with a square bracket here, and it's got commas between each of the entries, and it's splitting each of those entries up across multiple lines only in this output as a way of making it more readable, because if it put it all in one line, it would be a really, really long list that would be kind of harder to read than the way that it's laid out here. And one of the things that I want to point out is that this hyphenated word, grey blue, is kept together as a single word, so that the hyphen there won't be split. And that's one of the things that it's really important to remember in this circumstance, is that special characters like that will probably also be included. So let me show you what I mean. Let's go back to our sentence variable that we defined, and let's put a full stop at the end of the sentence, right? This dot at the end, which makes it a bit more grammatically correct anyway. Rerun that cell to redefine the sentence variable, and then run sentence.split on it. And what you'll see is that the dot appears still in the last word. And so you need to be a little bit careful about this kind of thing, because characters like that will probably still remain when you run this kind of split operation. There are other methods for string objects that can be used to remove those kinds of characters. But yeah, you'll need to go look up what those are, I suppose. And in general, I just want to encourage you to be a little bit careful before doing this kind of thing, especially if you're working with a really large amount of text, because you may end up with subtle differences depending on the special characters that are included in the text as well. The other thing to mention is that you should remember that Python treats uppercase characters as completely different from lowercase characters. And so if you wanted to, let's say, count the number of times that the word this appears, you'd need to consider that this beginning with an uppercase T will be counted as a completely separate, completely different word from this spelled all lowercase or all uppercase, I suppose. But yeah, this is how you would split up a string into words rather than into characters. And so you could, if you now wanted to get the third word, say sentence dot split, and then after that you put the square brackets with the index of 2. And what that's going to do is it's going to perform this indexing lookup operation on the result of sentence dot split, and we get the, which is the third word in that sentence. I think that answered your question. I hope it did. The other questions that are in the Etherpad, I'll make sure that we make time to cover those tomorrow. And I hope you will also learn a bunch of other helpful, useful things as well when you come back tomorrow to join us again. Thanks for being here. Thanks again to Kautar for teaching the first part of today. And I'm really looking forward to coming back tomorrow and again on Friday to tell you more stuff about Python and also Git and GitHub. Cheers. Enjoy the rest of your day.